Hi everyone, my name is Mihovil Bartulovic, and today I will be giving you a presentation for our BRiMS challenge paper titled Reopen America, Analysis of Twitter Data During the Anti-Lockdown Protest. This work was done with my colleague Tom, as well as my advisor Kathleen Carley. First, let's start with the overview of the presentation. I will introduce the notion of modularity vitality and the Reopen American dataset in the background, basically the method we use and the dataset we use for this analysis. Then we will apply this modularity vitality to the user-user communication networks, as well as for the URL analysis of the tweets. And in the end, I'll give conclusions to the whole paper. So first of all, to introduce the modularity vitality, we need to understand what is even Newman modularity. What does it represent? So Newman modularity for a graph G and partition of a graph G, which is this capital C, if we know the total degree centralities of the nodes, as well as if we know the indicator function, but well, indicator function is pretty simple. It's 1 if these two elements in the indicator function are equal, otherwise it's 0. As well as if we know the total number of edges and the adjacent matrix of a graph, we can calculate basically how well does this partitioning of the graph, this capital C, fit the graph G. So basically Newman modularity will give us a value between 0 and 1. And the closer to 1 is, the better the fit of the partition is to the graph itself. So basically, the better the grouping is. So we take the Newman modularity and we basically say, okay, what would happen if we remove a node, let's say I? In a way, we will check how impactful is the node I to the original network, the original graph G. And we do that by saying, okay, modularity vitality V sub Q of the graph G given node I is basically the Newman modularity minus Newman modularity of that graph with the node I removed. And this transitions the Newman modularity, which is from 0 to 1, to a sign metric from -1 to 1, which will have some cool implications in terms of social science later. We'll get to that later. But now let us just quickly introduce the data set we used. It's Reopen American data. We collected this data from April 1st to June 22nd of this year, using different keywords and hashtags, something like Operation Gridlock, Open Up, Reopen, Liberate, or Liberate XX, Open Up XX, where XX is just the state name or the state code. The dataset is fairly large, 3.6 million users, almost 10 million unique tweets, decent amount, 150,000 unique hashtags, or more than 500,000 unique URLs. And the size of the networks per day for user-user networks, all communication networks, is around 167,000 on average, and it peaks out around over 660,000 on the June 6th. So a fairly large data set, and we can see here the analysis, kind of the trend of the data over time. We can see that obviously number of links correlates to the number of users or the node count over time, which makes perfect sense. So the question is, why do we use modularity vitality as the method to analyze the data? Well, first of all, given the data is large, modularity vitality is actually a really quick method that we developed. It parses through the big data set in almost linear time, so it's really quick and fast to use. Also, it gives us the answer to the questions like which user, who is central within or between communities. And for this, to answer this question, which is a pretty interesting question, is we will group the networks on a daily basis, make user-user all communication networks. So basically retweets, mentions, quotes. We will all use that to make the kind of adjacent matrix of the graph over time per day. And then we will calculate the modularity vitality of all the nodes. And so if we get the negative modularity vitality, so we know it can go from -1 to 1, the negative value means that that node itself, that day, acted as a hub between communities. While if it's a positive value, then we know that node at that day acts as a bridge between communities. One thing to note is that we do the calculations per day. So basically, kind of the modularity vitality of that node is a reflection of the actions of the entirety of the day, not like throughout the day itself. And we investigate only highly central users. So we said to show only users that are above 0.01 value of modularity vitality and below -0.005. The symmetric bound is due to the asymmetric nature of modularity vitality, and these bounds might be fairly low. You might be thinking they're fairly low given that the modularity vitality is between -1 and 1. but we need to think about it. There's almost 3.6 million users. And if you look at it like 1 over 3.6 million contribution of each node, which is not exactly that. So this means that like this bound here is actually saying, oh, this user is almost as influential as almost 36,000 of other users. So makes sense to take it into account. And if we plot their modularity vitalities over time for the user to meet this threshold, we will see a couple of interesting users, and obviously somebody who we expected to see, which would be at real Donald Trump. We definitely expect to see president here, as he's one of the most influential users on Twitter overall, but especially in this data set because it's fairly right-leaning data to the to the most extent just due to the whole nature of reopening America and Operation Gridlock. But in the beginning, we see 2 spikes, which is the Rockwell report and Lisa #1 fan. We'll get into them later. Then we also see the Ziba lady spiking a bit later, but into the negative. And then we see interesting stuff happening with Joshua Potash, which actually spikes in the negative, then goes up into the positive. We'll also touch on that bit, in the next slide. So Lisa and the Rockwell report, they, as I said, they were highly central, highly important bridge nodes in the beginning. They did amplify each other. So Lisa basically retweeted Rockwell retweeted Twitter. They both targeted C-SPAN talk shows to discuss the open up and reopening America, but they never called for protest. The Rockwell report, basically, it's they call themselves the Real News, website, and they're not fairly active. They do have some articles, and they're all pro-Trump, but they don't post as often as as any big outlets. Ziba and people like Ziba, basically, they're more central, but within their communities, within its community, closer to the Operation Gridlock, and Ziba actually called for protest, including dates and times of the protest itself. While the last important user is Joshua Potash, is a popular figure in the opposition, so more left-leaning person, and basically he made a really interesting transition from being negative to being positive, which is really rare to see. So some glimpse at the Rockwell report. This is a tweet from Ken Weeks. Ken Weeks is one of the writers for Rockwell report, and we can just see that, just from the graphic itself and the title of it, that where they lean and what kind of message they amplify each other. So it's kind of like it was pre-Operation Gridlock kind of echo chamber between Ken R. Weeks and among these people who reply Ken R. Weeks, there's always Rockwell report, leads #1's fan, and so on and so on. Now let's do the same analysis, but for the URLs. So which URLs are being shared in the conversation? Which URL is more important? The way we look at this is like every time a URL is shared, we will look at the modularity vitality score of that user at that time for that instance for that day, right? And we will look for the patterns, like, if the bridge, like somebody who has a positive and large modularity vitality at that time, sharing the link, does that kind of correlate with the URL share spiking? Or it maybe even spike if its URL share is spiking if it's shared between the communities. One thing to note is that this kind of approach is biased because we are doing the per day modularity vitalities. So basically the daily, modularity vitality, we include all the shares of that link and those tweets over time in the calculation, while the share might be happening midday. So it's not actually exact modularity vitality at a point in time, but at the end of the day of when the user shared its URL. And one interesting example is this basically URL from Washington Examiner on the Rand Paul's "Our only hope rescuing this great country is reopening the economy," and we can see that initially there were some shares, like less than a couple of shares, and then this highly community central node, so Hub, shared it and it spiked. It spiked, but also the growth then kind of staggered, and then both the hubs as well as the bridges shared a node all of a sudden, and then it spiked. And we can see this trend for different other URLs that you can find in our paper. But it's an interesting observation to see that URL is definitely spiking when hubs and what bridges share the URL itself. So in conclusion, modularity vitality gives us a robust method to find important nodes in the community creation, and it's also really scalable. So it's nice to use on large networks. Obviously, early users kind of targeted talk shows, radio talk shows, and they were not calling for protest, but